Today I am going to talk about Gauss-Seidel method. Gauss-Seidel method gives improved iterative solution. Here are some key features of Gauss-Seidel method. Gauss-Seidel method uses updated values immediately. It gives faster convergence than Gauss-Jacobi. So for this Gauss-Seidel, we will take initial guesses. x0 is 0, y0 is 0 and z0 is 0. Now here is the system of equation. 10x plus 2y plus z is equal to 14, x plus 5y plus z is equal to 11, 2x plus y plus 10z is equal to 28. Now from this system of equation, I'll formulate the iterative formula. So from this first equation, so if I rearrange, so that x will be 1 by 10, 14 minus 2y minus z. From the second equation, we will get formula that y is equal to 1 by 5, 11 minus x minus z. So here k is number of iteration. And then from this third equation, we will get z is equal to 1 by 10, 28 minus 2x minus y. And we also know already that x0, that is 0 initial guess, y0 is 0 and z0, that is 0. So using that, we will do the iteration. First, here is my iterative formula. So x is equal to 1 by 10, 14 minus 2y minus z, and y is equal to 1 by 5, 11 minus k minus z, and z is equal to 1 by 10, 28 minus 2x minus y. So initial value, we know that x0 is 0, y0 is 0 and z0 0. Okay, so from that I am going to calculate x1. So I am plugging x0, y0 and z0. So here I am calculating that x1, so I am plugging y0, that is 0, z0 0, so we will get 1.4. Now using this x1 value, updated value, I am plugging in that to calculate y1. So 11 minus 1.4 minus 0, that is by divided by 5, 1.920. So using that updated value, so 1.4 and 1.92, so I will put in that third equation. So that will give 28 minus 2 into 1.4 minus 1.920 divided by 10. So that will give 2.328. So now using that, I am calculating the error, relative error. So my initial value is 0 and I am calculating, already got that x1. So from there I can calculate the relative error. So all our relative error are 1, means 100% error. So I have to go next step. So now here remember, so key difference from the Gauss-Jacobi. So here used new, that is x1. So after calculating that x1, so immediately I am using that value to calculate y. After getting that x and y, I am again updating, I am taking that updated x and y value and putting that z equation, this third equation, and I am getting that z value. So that way it gives that faster convergence than Gauss-Jacobi. But Gauss-Jacobi, what we did, we are not updating the value, we are using old value. But in Gauss-Seidel we are using updated value. So now after getting x first iteration, x1 1.4, x y1, that is here, y1 is 1.920 and z1 2.328. then I will go that second iteration. So here that using that value, so again we are calculating x2, so that is 0.783. so using x2, so we plug that in y2, so we'll get 1.578. getting that, now we got x2 and y2, so that we'll use in that to calculate z2, so we'll get 2.486. now here we are calculating the error. So for x, so earlier that x value is so now current value is 0.783, earlier is 1.40 divided by 0.783, we are getting 0.441. similarly for y, we are getting 0.217, z 0.064. so here maximum error is 0.441. earlier error was 100%, now here in second iteration that error got reduced and we got that 44.1% error. So now if I go for third iteration, so using same value, so x2 we got 0.8783, y2 we got 1.578 and z is 2.486. so using this value again I'm calculating x using y2 and z2, so that is 0.836. now y3 I am taking updated x3 and zy2 value, I am getting that 1.536, and z3 I am taking updated x3 and y3 and I am getting 2.479. now again I am doing the error calculation. So x earlier it was that 0.783, current that after iteration 3 I got x is 0.836. so if when I calculate the relative error, so relative error is 0.063. for y similar way 0.027 and for z that is 0.003. so now here the maximum is 0.063 and that error right now is 6.3%. now if I do that iteration 4 similar way, so my error is going down to 1.1%. similar way I am calculating x4, y4 and z4. so now here maximum error is 1.1%. now if I do that iteration 5 similar way, so now my error is 0%. so now here x5 is 0.845, y5 is 1.535 and z5 is 2.478. so these are my solution. so now this is the table of all this iteration. so if you see that iteration 5, that x is 0.845, y is 1.535 and z is 2.478. so this is these are the iterative solution of that linear equation. so now from here, so my final solution is x is equal to 0.845, y is 1.535 and z is 2.478. now if I plug that x, y and z in that original equation, so we can calculate what is the value of the left hand side, means 10x plus 2y plus z. if I plug x, y and z, I'll get 13.998. so that is approximately 14, means the same thing that is given in that original equation. Similarly second equation will get 10.998 approximately 11, and third equation 2x plus y plus 10z, so we'll get the 28. so now from here we got that the solution. now here is the convergence analysis. so started with initial guess of all zeros, so rapid error reduction in the first 3 iteration. so iteration 1 100% error, iteration 2 44.1% error, iteration 3 6.3% error, iteration 4 1.1% error, and iteration 5 0% error, means complete convergence. so here converged in 5 iteration faster than Gauss-Jacobi's 8 iteration. so I have already done one calculation in my other video. so there by using Gauss-Jacobi it took nearly 8 iteration, but using Gauss-Seidel only 5 iteration we got the result. so final solution satisfied all equation with error less than 0.002%, 0.002. so Gauss-Seidel is very faster than Gauss-Jacobi. so that way we can solve the system of linear equation. and here final solution is x is equal to 0.845, y is equal to 1.535 and z is equal to 2.478. so that's it. Thank you.